I'm Sean Carroll. I'm a theoretical physicist at the California Institute of Technology in Pasadena, California. And I think about how the laws of physics came to be, what they are, and how they make the universe that we live in. So the Big Bang doesn't break any of the laws of thermodynamics. The two big ones are the first law and the second law. The first law basically says that energy is conserved. The second law says that entropy increases, the disorderliness, the disorganization of things increases over time. So the Big Bang, we don't know if it was the beginning of the universe or not. If the universe has zero energy total, which is possible, then the Big Bang could have been the beginning of the universe, and it could have just been the first moment in the history of the universe without violating conservation of energy, because energy is zero. The second law, the entropy increasing, is an interesting case because near the time of the Big Bang, entropy was very, very, very low. That's why it's been increasing for the past 14 billion years. So that doesn't violate the second law, but the question is, why did the Big Bang have such a low entropy? And the answer there is that nobody knows. This is an open question for cosmology. Why was the condition near the Big Bang so special, so organized? There are, as you might expect, many theories and many guesses as to why the Big Bang had such a low entropy. I'm responsible for some of them myself. For example, maybe before the Big Bang, maybe there was something before the Big Bang, and before the Big Bang, maybe there was a condition where the entropy was very, very high, but maybe the laws of physics are such that there is no maximum value for the entropy, so that no matter how high the entropy gets, it can always get higher. And maybe the way it gets higher is by spitting off a new universe, by a quantum transition that bubbles into existence a whole other universe that breaks off from its parent and goes its own way. Maybe that's where we came from. Maybe our Big Bang started tiny and low entropy because it just pinched off from a larger high entropy universe. If there are many different universes, we don't know what the laws of physics are going to be like in the other ones. We have theories, of course. According to some of those theories, the laws are exactly the same in all the different universes. In other models, some of the laws are different, but there's still basic principles that are the same. So for example, the idea of electric charge might be slightly different in one universe than another, the charge on one particle or another, but the idea that charge is conserved is probably true in all of the different universes. The idea that energy is conserved is probably just true no matter what universe you live in. Well, if there are different regions of space where there are different laws of physics, apparent laws of physics, what we call low energy laws of physics, then probably the boundary between them would be pretty crystal clear, actually. It's very much like space itself is in a different phase from one place to another, in the same sense that we use the phrase phases of matter, right? Ice, liquid water, water vapor, different phases water can be in, and you know where the boundary is between the ice and the liquid water. In the multiverse, it's like different regions of space are in different phases altogether, and we'll probably be able to know where the boundary between them lies. As far as we know, there's no necessary way to be able to observe these other universes, even if they do exist. Now, that's not necessary. There's possible ways to observe them. If we get lucky, two universes can actually bump into each other. We could actually see the sort of bruise on our universe when we got bumped into by another universe at very, very early times. Of course, we really don't mean universes at all. What we really mean is a region, an area of our universe that there are different regions that have different apparent laws of physics. So this would be like a bubble in a pre-existing space, and the bubbles grow and the bubbles can bump into each other. How would you know? Well, if it happened early on in the history of our universe, it could either dump energy into us or leach energy out of us. So there'd be a region of our early universe that was at a slightly different temperature than the rest. Now, we have a record of what the temperature was in our early universe from the cosmic background radiation, the leftover radiation from the Big Bang. So what you do is you look at this cosmic microwave background radiation, and you ask, are there regions, hopefully circular regions, where the temperature is a little bit different overall? Now, of course, we've done this very, very carefully. We've seen nothing. There are tiny variations, but they don't look like circles. They don't look like universes bumping into each other. So the parameter space for this to be real is very, very small right now. I suspect it's not going to happen, but we'll keep looking. Otherwise, we just have to ask, is this idea of the multiverse the best way we have of explaining the universe that we do see? And if not, we'll abandon it.